Hi guys, welcome to day 12 of Algebra 1, Semester 2 Summer School. Today we're going to continue looking at analyzing quadratic graphs. I'm going to do the odd problems as an examples with you, and then the even problems are actually going to serve as your formative assessment today. So please make sure that you are answering them correctly. I will be going over them. I will be grading them for accuracy as part of your formative assessment for today. So just be aware of that, that there will not be a second formative assessment today. It will be just this. So I will have you submit this to Google Classroom, and so that'll work. Okay, so let's work through, we're going to do graph A together, and then I will have you do graph B. So to find the axis of symmetry for graph A, remember the axis of symmetry is the line that divides the axis or the parabola into two equal sections. So that axis of symmetry is going to go through the vertex. So this line I'm drawing right here, this is the axis of symmetry for our graph. And the equation for the axis of symmetry is x equals whatever coordinate it's going through. So this is going through x equals -2. So that would be the axis of symmetry for that graph. The vertex is that turning point of the graph. So when it's asking for the vertex, it wants the coordinates of that point. So we want to write the x-y pair. So x is -2, y is -1, 2, 3, 4, 5, -5. Then it's asking if this point is a maximum or a minimum. Since this parabola is opening upward, that means that this is the minimum value. It is the lowest value that the graph is going to go to. If your parabola opens down, that means that you're going to have a maximum value instead of a minimum value. All right, now we want to identify the domain and range. Remember, domain is all of the x coordinates. And those arrows are pointing, the left-hand arrow is pointing up and left. So we're going to go all the way from the vertex to the left. And if we look at the vertex to the right-hand side, that arrow is going up and right. So we're going all the way to the right. That means that our domain is going to be all real numbers. So the domain is all real numbers, meaning that we can put any x value in and get an answer back out. Now our range has a lowest point because that's our minimum. So where y equals -5, that's going to be the lowest value, and since those arrows are going up, that means we can be anything that is greater than -5. So our range, y is greater than or equal to -5. Now, to find the equation, we want to look at some features of the graph. So, since this opens up, that tells me that the x squared term is going to be positive. So I can eliminate option C and option D because those would open down because that x squared coefficient is negative. So now we want to decide if we are going through graph A or graph B. The next easiest point to check is your y-intercept. This graph has a y-intercept at 0, -1. And the C value of our parabola is the y-intercept. Well, both of those y-intercepts are still at -1, so that doesn't help me to figure that out. Couple of different ways we can get there. I would probably think the easiest way is to use the axis of symmetry equation to figure out our answer. So that axis of symmetry, remember that this is where we took the opposite of B divided by 2A. So if we look at graph A, B is -4, so we want the opposite of -4. divided by 2 times 1. Negative of a negative is a positive 4 over 2, which gives us x equals positive 2 as our axis of symmetry. So A is not our answer because we want x equals negative 2. So let's try B just to double check. So if we want the opposite of positive 4 over 2 times 1, which would be negative 4 over 2, which is negative 2. So option B is our answer. And we can eliminate the other 3 options. Okay, I'd like for you to repeat that process with graph B. Submit your work to Google Classroom. Today's nice and short. Then make sure that you've got everything else done. Thanks, guys. Have a good day. Bye.